Harun, Harun, I missed to join earlier, so seems I missed important time travel related.
No, we haven't discussed anything yet on the concepts. We were just talking about more onto the relationships and the how we can collaborate with each other um, to get more value out of the our discussions, our training,
Okay,
and
thank you.
you know, yeah, interpersonal relations, how they are important um, while we grow together. Uh, so okay, let's get back to this. As we go through each of the topic, then we will talk about it and discuss more. And Sahil, DK, and Nag, others can and Prasanna, whoever has more information can chip in, and we can have a good discussion on this. So I'm just creating a new database here. Basically, if you look at the catalog, I think the database already has. We have creating a new database called Delta DB, and we will be creating tables in this for this exercise. Okay, and then format check, auto optimize. These are some of the features that we just enabled for performance default properties. Now here we have a checkpoint directory. We know we need a checkpoint directory for streaming. So it's just the defining a temporary path for a checkpoint directory. And then we have a user defined function, which would give, it's just kind of random choice in one of the states. So whenever you call this function, it will randomly return one of the states. So these are all Python functions, nothing much to delve about, deep about, but to know the basic Python functions or Python way of writing the functions and syntax. Now, generate and append data stream function. This is another function. So what it does is it creates a stream from the rate. Anybody remember we did streaming based on the rate format?
Yes,
Yeah,
I
it gives
think
couple of
it
columns, right?
automatically it randomly generates two columns,
Yes.
random data.
Yes, exactly. Yeah. So we randomly generate two columns, and from that value column, what we are doing is we are just creating new columns using that value. Uh, just some, it's like generating some test data here, synthetic data using the rate option. Okay, it keeps continuing, and type whatever type we are sending in, whether it is batch or streaming that we are doing. So mostly, so it's just to generate. So default value here, if you see, we discussed in the Python functions, type is equal to batch. So default value is batch if you don't specify the type. Otherwise, if you send in like streaming, it will use the column type as streaming to just identify how the data is coming into the table, either through batch or through a streaming kind of thing. And then we have these four columns. Okay. Stream data, you're selecting this and writing this data into a table format and table name, whatever we are giving. So whenever you call this function, it will create all of this and return you the query with all of this table names and the stream data, using the stream data, right? Okay. So another function here, stop all streams. It's basically when you go to end of the notebook, when all the streams are done, you want to stop, you just call this stop all the streams, clean up paths and tables. You can just create this all temp folders and files which you want to clean up once you are done. So this is one of the functions that we have written. So all of this is just, you can actually manually write all of this in different cells, write the commands to do this, or just function that they have defined to use. So this is how you have to write when you actually in the production environment or in the live industry, when you are writing notebooks or any functionality. It is a best practice, right, to have functions defined for a proper functionality, and also use proper the exception handling or error handling kind of a thing. Okay, so these are just reusable functions that we want to use. Okay, so now here we are creating, so let me just as we go along start run this. Okay, now we are creating a directory called loans parquet in the temp in this folder path, and we are getting data from this URL. So it's kind of API call to pull the data and write it to this location. Okay, this is the data that we are going to use for exercise. So remember here we said when we are writing the data, there is a type called batch or streaming. So for the batch, we will use this file that we are pulling from this location. So normally, even in the when you go right into the live projects, apart from the streaming data that comes in through any of the even the HubSpot model, like streaming tools like Kafka or Event Hubs, or through files coming in or from data, there'd also be like API endpoints where you kind of pull the data from. You connect to an API endpoint and then you pull the data. So that is also one valid source, right? So most of some of the ETL tools have those connectors where you can connect to the other systems through API and then pull the data periodically based on incremental data or the last updated date type. So similarly here, we are getting this Parquet file, which is there in this location, and then storing it in our temp location. Okay. See here at 602.1438, this is saved. Okay. So we can actually check that here. This is the Parquet path. We'll just do. So how do we check the file at the path? Anybody?
dbutils.fs.ls.
Exactly. dbutils.fs.ls, and we give the path that says here it's storing at this path.
Is the path end? Does the path end until loans.parquet, not go loans.parquet? Yeah.
No, it should still give the file name as well. No, I think the root is different. So let's see, does it say file colon something? Yeah. So this is the path where loans.parquet is, and this is the size of the file. Okay. Now what we are trying.
There is a slight difference between DBFS and file prefix. A file is some other option recently Databricks introduced, where you can save configuration files, different files. So there is a slight difference. I don't remember on top of my head, but please keep a placeholder, Harun. Make sure our team gets clear what is the file prefix, what is just DBFX prefix, what is the ADLS prefix, etc. Please keep a placeholder.
Yeah,
We will talk.
we'll talk about. Okay. So here we are using, like we already earlier we discussed, if we have CSV, we have JSON, we can just create a table using the path to that file with the format, Parquet format, or we can create a table using Delta, or you can convert these tables, read it, and then write back as Delta, right? So that's what we're trying to do here. Parquet path, we are reading that file with column type as batch. Okay, so we are adding another column to identify this data as batch, and with timestamp, current timestamp, and then we are saving as table loans delta. Okay, so this is just creating a delta table, loans delta, on top of this Parquet file. Okay. So now
Delta table means same Delta format.
yes.
Okay.
So if we have this, right, so if you have this create table, so we are trying to create another table, loans delta 2. It's saying use delta. Using delta, select star from Parquet dot this loans Parquet. It will not work, right? So because it does not have, it's not converted to delta, so you cannot select Parquet dot this files here. Okay, so it says path does not exist, this path. So now you can try to convert to delta, the same path. So because this path does not exist, it's already converted to delta, we are stored as loans underscore delta. Okay, so when you want to create table, it is meant to fail here because it says no upfront schema definition is needed here. We'll check this. We'll come back. There's a slight confusion here how to transfer between Parquet files that we create as delta and how when we read and write back as a delta format. So we'll just put this as a placeholder and we'll come back onto this. But for now, let's continue with the loans delta that we created. So this part is clear, right? So we are reading this Parquet file that we have downloaded, and then we are reading that Parquet file, format is Parquet that we are reading, with adding these two columns and then writing in the delta mode. Okay, so this loans.delta is what we are using for, for our exercise today. So we have 14,705 rows in this table. So you can go and check in the catalog. So delta DB, you have loans delta. So this is the data, and the this is the schema of the table. Got it? Any questions, guys? Anybody? Subbu? Nag?
Yeah, no.
Are we clear? We're just getting here data, the Parquet file we are reading. It's simple. We have been doing this, for a long time now.
Yeah, we are good. Thank you.
Yeah. So Parquet file and then writing to loans delta. And that is our data here, 14,700 rows in this. Now, what we are trying to do here is we are trying to generate two streams. Okay, streaming data. What we're trying to see, generate two streams that are parallelly writing to the same table. Okay, so how we are generating this? So here we are seeing that table format is Delta that we are going to write to. Table name is loans Delta. Schema okay is true. Type is here. We said stream A and stream B. Batch we had already written the data here. So the type for this is batch here. So batch data, we have 14,000 records. Now we are going to create two streams and then write into the same Delta table using two different streams. So how do we differentiate and generate data with these two things is, this is when you call this method, generate and append data stream, which is a Python method we defined here. If we go back, generate and append data stream. So type we are differentiating, stream A, stream B. Schema okay, true we are sending. Table format Delta and table name is loans Delta. Now, how is this generating the stream? Using the rate, and we have some arbitrary values like 10,000 plus the rate value. It keeps on increasing. Funded amount, some random value we are generating here. Paid amount also based on this random value. Again, we are generating some number. Address state is random state, which is like one of these four. It will give some random state. It will return. So that we will use here. And type is stream A or stream B. So using that stream data from this, we select all these columns and then write to the stream. So when I run this, there are two streams that will be starting, reading from the rate and generating the data and writing to the Delta table. Okay. So here we are displaying from the Delta table, group by type and count, order by type. So what we are doing, as the streams are writing, we are trying to display what is the count of the streams, the rate at which the streams are writing to the table. How do we do that? We have a group type to identify whether it is a batch or stream A or stream B, and you get the count. You know, it's a continuously increasing count because the streams are writing to it. And then we order by this type. Okay. So let me run this, start the stream query A, query B. So the Spark jobs have started. Now we can check the data here. Okay. So see here, batch data. So if you see 14,700, this is batch data. This is stream A data that is writing 6,500. And here, this is stream B data, 5,500. So see this batch data, if you can see, it does not change, right? So it's already written batch. So 14,700 is fixed. Did you observe this? So this data is constant. Now stream A and stream B are continuously writing to this table. So it keeps increasing the count. Every time you read the date table, read the stream, it's continuously increasing. So now stream A is written 33,000. Stream B is written 14,000. Do you guys get this? Any questions on this?
Why the batch? So you told that it did not change, right?
Yeah,
So how much data?
14,700. Okay. So stream is continuously writing because it's still running the stream. Batch is what we had already written once here. We read the
Okay.
file and we saved into the table. That's it, done, batch.
Okay.
14,700 rows. Now, whatever we are generating the data and streaming the data to write into this table is from type is stream A or stream B, two streams. So now stream A is 33,000, stream B is 54,000. Batch is still same. So based on the rate that we do, we keep writing this data. So it keeps generating this. Okay.
Yeah, got it.
Okay. So yeah, so I think we have enough data on this. We can pause this now. We can do. So this is another, just reading the loans delta address state. So we'll just go and stop all streams. Okay, so now we are stopping the streams A and B so that whatever data we have generated, it is good enough. Stopped all streams. Okay. Stop all streams. What we did, we created a function here. We're just calling this function stop all streams for S in spark.streams.active. So whatever streams are active, you will loop through that, iterate through that, and stop. Call the stop function on the stream. So it will stop all the stream functions. And then we remove the checkpoint folder, whatever checkpoint directories it has created.
So it stops streams only in this notebook?
In this notebook.
Or...
No, only in this notebook. The scope is in the, it should not, right? It should not stop somebody else is running the streams. It should not stop the entire system. It is, the scope is limited to only this notebook. Because when you say Spark here, when you say Spark dot, right? Spark context is only limited to this notebook because it's a new context that is created for this notebook and it lives as long as your notebook is active. Unless you kind of last time somebody mentioned that you're calling another notebook from this notebook. It's just like a traditional classes and methods, right? You declare a variable local. It is within the method. You can declare it at the class level or you can declare it global, right? So similar concepts here, but here for the Spark context, by default, it means everything only within this notebook. Okay. Now, so we have the data. Let's check. So now 231K data we have total. Okay. Out of which 14,000 is batch and the rest are from the streams that we created. So we can see at each individual times, right? At this time window, we had only batch data. In this time window, we have stream A, stream B that has come in timestamps. So this is how the data is streamed into the Delta table at each 5-minute windows or whatever, not 5 minutes, seconds, 10 seconds window. So for each 10 seconds, this is how the data is pulled into, written to this Delta table.
Did you create this visualization, Harun?
No. It is default. In notebook will give you, right, visualization here. So it will automatically give you the visualizations. All we did is only display. If you see is group by, then it will show this visualization. And here also, if you see, right, it's a default visualization you want to show. Address state, it shows a map. It's interesting, actually. You can actually do visualization, customize the plot. So as we said, these features are available by the Databricks notebook, not by Python. Databricks notebook, and when you do the display, right? So these features are the extra features that are provided by Databricks to do some analysis, quick analysis in the notebook. See here, you can change. If it is a state data, you can use map, or you can just use bar chart. So it just gives you a state like this. It's some kind of
Oh, so you can add it to
Yes,
a dashboard too, because not everybody will access to this notebook, and when this notebook runs, other users can view this in the dashboard.
yeah, you can, but normally that is only for the quick analysis when you are doing. See, for example, you are the developer, right? So you're developing this, and normally it is consumed by a BI application. So when you do aggregates, sum and all of this is your gold layer. Remember, in the medallion architecture, you go from bronze, you do transformations in silver, and then you do aggregates in the gold, correct? So what we are doing here is group by state, and then we are doing count. How much, in how many loans records are there for each state. So this is aggregation. Let's say we write it to a gold layer. Normally, the consumer of this data, business, will have some kind of BI tools to read this. They will not look at or read from the notebooks or these dashboards. So they have their BI tools like, Power BI or Cognos or Tableau, whatever it is. Now those tools will read from this table. Whatever you get this group by data, you write it to a table, right, in gold. You do the aggregations, and then you write this data frame to a table in the gold. So the BI tools will read from those tables and do the visualization on those, because they will have more features on the visualization tools to partition, to show charts, to show so many things on the BI side of it. Now, if you want to see how this looks like on the BI side, or is this data correct, is this aggregation correct? So you can use this quick visualization just for like unit testing kind of a thing. For data analysts or business analysts, they want to look at. Okay.
Okay, thanks.
Yeah. So we don't normally expose this to business to come and look at, the dashboards created by the notebook. This is very raw information that useful for the developers to look at, to troubleshoot, to see things if it is good or not. For example, if you see here, you can quickly make out that, yeah, there are only 4 states, right? Maybe it's true, maybe it's not. Maybe the business is only in 4 states, or maybe the business is in all the states, but somehow the data is not coming for other states. That's when you go and check, are we doing correctly or not? And then we go and see, okay, here we are only providing 4 states to get the data from, or maybe this is correct, or maybe we need to add more states here to get information. That kind of quick analysis. Right? Does that answer your question?
Makes sense, sir. Thank you. Yeah.
Good. Okay, great. Okay, let's continue here. So that is the, kind of a refresher writing streaming data. Now, we want to see how the ACID transactions support is there on the Delta table, right? So see here, this is another, kind of refresh. So what we did till now, we did from batch, we wrote to the table bronze. we did from streaming, we wrote to the table. And then we can do a filter clean augmentation here from these tables as even when the data is coming in. And then you do aggregations and write it to the gold. And as I said here, see, we have BI, Power BI, Power BI, any BI tool like Cognos, Tableau, or BI, or whatever. So they read from this gold layer tables, aggregates, and display it in their UI. Or the ML, machine learning algorithms that we use to run from this. But sometimes like the ML algorithms also read from Silver if they need more data at the granular level, not at the aggregated level. So sometimes the data science can also read from Silver. Okay, so but business BI will always read only from gold most of the time. ML can read from gold or silver. Most use cases read from silver than gold. Okay, just give me 1 second while you look at this and let me know if you have any questions. I'll be back in 2 minutes. You can discuss meanwhile.
Can someone tell what is ACID? ACID. ACID properties of a table.
It's atomicity, consistency, and then durable. I stands for.
Yeah, Google it. It's okay.
I just did
You
chat.
can perform.
Isolation, durability, atomicity, consistency,
Yeah.
isolation, durability.
Super. Could someone talk about first one, atomicity?
Yeah. So atomicity means a transaction can either like complete, or it can be successful or it can fail. There's nothing like partial execution.
Super. What is the consistency?
It's like how different transactions are viewing the data at the same time. Like how consistent the data is for different transactions, like read or write at a particular time.
Isolation?
I'm not sure about that.
Anyone? You can Google and you can brush up and explain.
It's the order of the transactions. The order of the is required.
More clarity.
It's regarding the permissions of the user to update the table.
I think if you have a partial transaction, we have like a begin transaction and you started writing it and it did not commit, there are some dirty reads and stuff that goes on. If you try to read the transactions without logs, it ensures that either you get a correct transaction or not. It doesn't give you like a partially written transaction in between. It isolates one.
Let's put in this way. Suppose say multiple users are reading. Multiple readers are writing to the same table all at once, right? So isolation of the transactions ensure that suppose there is a concurrent transactions, they don't interfere, it can resolve the conflict also. Suppose say two people are writing to the table, then there is a concurrency, correct? So unless the key matches, see, some people may be updating some keys, some people may be updating some other keys. It isolates. So it doesn't wait. It updates their rows. It updates these people rows. So it isolates the updates. But there is a situation where even the same row get updated by two processes. Instead of failing, it waits for the one to finish, then next to do it. So it puts in the queue or something like that. So each request can occur as though they were occurring one by one, even though they are actually occurring simultaneously. So next, can someone tell what is durability?
It says once a transaction is committed, it will persist even in the system of even in the event of a system failure, such as a power outage or crash.
Correct, exactly. Durability means, suppose you updated it, but somehow a power outage, something failed, but that data will be saved. Ensures the changes to your data. Suppose you did some change, they are successfully executed transactions, they are saved. We're talking about the processes, not in your SQL, where they use the commit option also in some databases. But general, I said, a refresher. Let me share you this for your reading. Okay. Give me a second. Keep this in the mind. This is an entry question. Just get some clarity. You do some more reading and make sure you memorize a little bit. I shared you one link, everyone, in Databricks site. It tells you what is ACID, what is a transaction, what is atomicity, what is consistency, what is isolation. So you all know, right, in the non-Delta, when it is Hive in Hadoop world and before Delta, there was no transaction support on the blob storage. The Parquet files, etc., you cannot update. They are only append only or full refresh. So then the transaction support came. The first database that came in the cloud, I'm not talking about Snowflake, in the blob storage, especially S3, ADLS, or GCP. So the first transaction support that came in the blob storage is Delta. Now even there are some other open source projects like Iceberg, Hudi, H-U-D-A, Hudi. So these three is support the transaction support. So just like a Delta. But Databricks uses Delta. Even Fabric, Microsoft Fabric uses Delta. Amazon EMR uses Delta. That's briefly. But there is one more concept. It says your company has, some people have Iceberg already. They're implementing Delta. So Iceberg on some other system, Delta on the Databricks. So Databricks have come up with a concept called uniform. It means in your Spark, you can write a uniform storage where if you save a uniform transaction, it saves as a Delta into Delta storage. It saves as a Iceberg format in the Iceberg storage. But the way you write is the same. It's a uniform. I'll share that also. It's not urgent. People don't ask you a lot, but it's a good to read. I'll share that also. Yeah. So
Srini, can I add something?
Yeah,
so,
please.
Yeah, this is all when you're writing, to the Delta tables, right? So one thing when we are working with Iceberg tables was, yes, this is all definitely good while you're writing. While reading also, it's quite faster. That's what we've been told. When you're writing analytical queries, on the Parquet file is probably slower, but you're writing the queries on the Delta, Delta or the Iceberg tables, it's quite faster to retrieve the data also.
That is correct, because the metadata is stored in the, you don't
way.
have to read those Parquet files metadata. Instead, the transaction log has the metadata. That's a good point. We added. So, yeah.
Okay.
Okay.
Yeah, welcome. Mike. That's good discussion. So if we see here, we'll continue with the asset transaction support. And before that, we have define structure, enforce schema here, and evolve schema as needed. Okay. So if you see here, enforce schema and evolve schema. This is basically the schema evolution concept where the incoming data changes or had more columns in the schema. There's a new column added in the source and that is coming in as a new column. So how does Delta handle? How do we have that schema enforcement? So for that, what we do is, for example, the current loans Delta. So we know what are the database columns that loans Delta has, right? So if we look at here, it has loan ID, funded amount, paid amount, address date, type, and timestamp. Okay, 6 columns. So what if there is a new column added, say for example, credit score to this? So how do we handle that? Suppose the source system has added a new column called the credit score. They're calculating the credit score and sending that with the loan information. So to check that, what we are doing is we are creating new data frame here with a new column, that is credit score, integer type. And the schema, we are taking all the existing columns. See spark.table, loans delta table dot schema dot fields, which will give you all the columns of the current loans delta, the current 6 columns. Plus we are adding this struct field new to the schema structure. So now you will have 6 columns in the schema, new schema. And then we are generating 2 records, sample records, data here. So 1, 2, 3, 4, 5, 6, and then we are adding credit score at the end, new column for the data frame. So here we're creating the data frame with this data that we are generating. We are trying to add this new data to the existing loans delta table. This data with this new schema. So once you create the data frame, so you run this, so you have this new data frame with credit score column as well. Okay. You can also display this data frame, new data.
You spelled
You spelled it wrong. Display.
Oh, spelled it wrong. Okay. So here we have new credit score 649702. Okay. So now we are trying to write this data frame with this data into our loans delta table. So when you try to write this delta append as loans delta, so it will error out saying that schema mismatch detected, because the existing table has only 6 columns, but the new data frame that is coming in to try to store in there has 7 columns, which is the added credit score. So this is very important. One more interview questions for the Databricks or the Spark is the schema evolution. How do you handle that? So what you do for the schema evolution is there is an option called merge schema true. So for the table, when you write data, you put option merge schema as true. So when you give that option, then it will automatically add that new column, put these values into that table, and then the existing values for the existing record for that column will be null, because for the previous data, it will not have any credit score because we didn't give that. So these are the, see here, stream A, stream B, whatever was generated through this earlier had null value, have null values now because it has default populated this column for the previous existing data as null. So new data we have put into this with this loan ID with this credit score. So this is added. So if you see here, it's the same loan ID 99997 99998. These two loan IDs. Batch type is batch and credit score is this. So that is what is added, appended here to the table. Two new rows 649702 as batch for these two loan IDs. The previous existing data would still be same, still remain same. The value for the new column that added will be null. So that is the schema.
What is the difference between the top loans delta where you added a column versus the merge statement that you are doing? I didn't follow through.
Okay, let's come back here. You're talking about this?
Right, like in the schema, right, where you added the new column. That is also loans delta, right? Where you added a credit score column there. Yeah, in
Oh,
here.
this is just a data frame. There is no table here.
Oh, you created a data frame based
Yeah.
on the existing schema, and then you added a column to the data frame. Okay, got it.
So I'm just trying to generate, how the data is coming in. So there is a new schema. There's a new column that is added, that is coming in with this data, with the added column, data frame. So when you try to write this data with this new data frame into the table, it will fail because the schema does not match. The schema of the data frame here and the schema of the table does not match.
Got it.
That is why it's
Got
failed. But what we did is we put an option saying that merge schema. So if the schema does not match, you merge it. So which means that you accommodate the new column as well. So then it added that new column, made all the old records as null, and then we put a new column as values here. So this is useful when you want to enforce the schema. So if you want to fail, if there is a change in the schema, you just leave it like this. So then you will know, okay, the incoming data is not matching with the existing schema, then you take action. Or if you want to say, I am fine with new columns being added coming from the source, use this option so that whenever there is a change or add new columns are coming in, it will automatically get added to the existing schema.
Got it. Just to reiterate, so let's say I have some 10 files. In 10 files, I have, let's say five files have 5 columns, and the rest 5 files have 6 columns. So this, if I put this merge schema, it will still support the 5 columns and the 6 columns, right?
Yes.
Like it will go back and fail the first 5 because we added this credit score.
No, it will not fail. So that's why, right? It still adds null values to that data.
Thank you.
Okay, so that is the schema evolution concept that we have. Now we talk about the time travel. So basically when we said when we say there is ACID transactions support, where it supports insert, update, delete, not just the append, right? So what it gives you is the feature to travel in time, basically to see the data at any particular point of time, how the data looked like, the table looked like at a given point of time, whether it can be a version number or it can be a specific timestamp value. So it will create those keep snapshots. It will not create snapshots, but it will generate based on the transaction log it maintains for each transaction that is happening on the Delta table. So we will also look at that if time permits today or maybe on Wednesday, how the transaction log gets appended or modified with each transaction you are doing. But we have briefly touched upon, you guys are aware of the transaction log, right? How the Delta formats or manages the files with the transaction log. Correct? Guys are aware? We talked about it. Anybody? Subbu? Hari?
Yes, sir.
Okay. Yeah. So can also okay, we will come to that in another notebook about the transaction log. But for now, yeah, let's continue with this. So what I'm doing here is I'm checking the history of the loans delta. Okay, describe history. So it will show me all the versions of the table and the timestamps at which that version is created, what was the operation done. So if you look at this, version 0 is when we did create or replace table. This is the operation that was done on the table at version 0. Just created table with, so where we had the batch data at this point of time in this. Okay, it also gives you from which notebook ID that you did, what is the cluster ID, read version, all these things, operation metrics. See, number of files, 1, output rows. See, remember we said batch data, we had 14,705 rows, correct? So this is the data that was inserted using the, when you created that table. Okay. So this is version 0. Now, as you see, we have multiple versions here. So read version 0, you can ignore. So let's say we have streaming update after that. So we started 2 streams, stream A and stream B. And then we started adding data to the table, right? Guys, these are very important concepts. Specifically, you should talk about all of these in the interviews, how the Databricks Delta works, internals of Delta, just like internals of Spark.
What is the event that triggers this history, Harun? Is it the data update or is it both data and schema update?
It's both, basically. That's a good question. When you say here create or replace, right? So this is a DML. Both DML and DDL, both will trigger that. So this
Let's
is
say I'm writing
trying to
1,000
see the
rows.
history that is created.
Let's say I'm writing 1,000 rows. Does it trigger for every row? Does the version trigger for every row?
No. See here, version 0, it's all insert, right? 14,700 rows. There's just only one row, one version. You don't
That's
have.
a batch update because it's one-time update, right?
Yes. So
It's on the
every time
table
you
level.
have a single update, it will create the transaction. When it is done, then it will create a new version. Okay, so it's a batch kind of data, whatever the batch that even in the stream, right? You keep 5 minutes, 5 seconds or 10 seconds window, you read the data and you update the table. So that is one transaction. Even in the streaming, if it is micro batches, 1 second or whatever it is, whenever that is committed to the database table, the Delta table, that is when a version is created.
So Harun, a quick question though. So can you retrieve, like, for example, you want to go and get the version 2 of the table, can you go and retrieve that table?
Yes, definitely. Yeah, that's what we are going to see now. Okay.
Oh, okay.
Yeah, we will go through all of that. So here, so that is version 0. 1, 2 does not have anything. read, there is no read on that. So version 3, it shows it is a streaming update, and then it has updated some read version 2.
Shiva, just to add a point, not only retrieve, you can even roll back.
Yes. Yeah.
Oh,
So yeah, up to by default up to 40 days, rather you can roll back. That's
wow.
how it maintains. Yeah.
Okay.
Yeah, time travel. So default, I think it's a 7 days, but you can configure how much you want to have that history maintained for each of the delta tables. So output
Got it.
rows 6,500, 5,500, 8,500, how much is each batch has written, even though it is streaming. So within the streaming, you read every 10 seconds, you read a batch of data and then commit, right? So that is the data that is put in here for all of these versions. Okay, so now let's see how we use these versions or timestamp here. So very simple, you just write a SQL statement and then you do version as of. Okay, so if you do version as of 0 is we are going back in time to see how the table existed at version 0. Okay, so let's run this and see, then we'll talk about this. Okay, see, select star from loans delta, version as of 0 is this data and count is 14,705. Now, if I use the same sequels here, without the version, or simply, okay, just not spark.sql, we'll just try it. Okay. Where is the count? Where did the count go? Submitted. Okay, let's just take this and use in this. I just want both here to compare. Oh, sorry, I have to remove this version here. Okay. See here. Now version as of 0, the count is 14,000. If I don't use version, that is the current state of the table, latest version, the count is 231,000. Okay, you can still compare. Again, Purnima, you asked about the schema, right? See, as of 0, there is only 6 columns. As of current version, you see here, credit score is also there, but credit score is not there as of version 0.
Right. Yeah.
So it does not show credit score column here if you go to version 0. Okay. Now, so this is the difference. You get the latest version, a snapshot information if you don't use anything. And if you want to go back in time, you can do any version. and then see what is the data at that time. So the latest version we see here is like, 16 or 17 versions. So I can go back and do version 10 here. Okay. See, version 10, the data is 124,000. The schema is still not there. Credit score is not there even at version 10. So the credit score came much later when we added, I think, the last schema, about 17 or something, 16 or 17, 15 versions. So somewhere at 15, the latest, that's when the we got the new row with the added version. See, output rows 2, there's one file that came in 15, and that's when the schema has changed in this. So if you go to version 15, that is when you will get the schema. That is anyways the latest version that we have. You got this? Everybody clear? Kishore?
Yes, Arun.
Chandra?
Yes,
Yes, sir. Clear.
Yes, I'm good.
Okay, great. All right.
Harun, is there an interface for this job, the streaming job that you ran, or do you have to type that command, describe history to know the timestamp of the?
No, this is the metadata that is the metadata that
Right,
is maintained. It's just like your SQL, right? Describe table. So in
right. Let's
describe
say
table, you
I'm writing
have to add history.
let's say in the same streaming job, I'm writing three data to 3 delta tables, and at 12 o'clock in the midnight, I want to roll back. I want to know the versions for all 3 tables. What is the version number that happened on all 3 tables to roll back all 3 tables?
No, you cannot use the same version number, right? Because it's not only one stream table that is one streaming job that is writing to 3 tables. So the tables might be getting updated from other jobs, not just your job, right?
Right.
So one table might be at version 15, one table might be at version 20 when you are writing into these tables. So when your job writes at 12 o'clock to 3 tables, so table 1 might be moving to version 30, one table might be moving to 50, one table might be at version 5. So it's not, you cannot use the same. So you have to individually check what is the version that was written onto that table, and then roll back these tables separately, not by the job. So if you see, you can identify the versions from this using notebook or the timestamp that this ran. So all that analysis has to be done. It's not like the one job will get the same version number and all the tables.
Just to add a point, Punwa, you also have, when you go to catalog, when you open the table, there is a history tab, which gives you the list of versions.
Okay.
But the point is, Harun is right, that a version is a table property, not job property. So think from the table only. How many updates it happened? Is the table changed? So 2 different versions.
So this
It's
is like
rare
auditing only, right, Srini? This is like auditing only.
Yeah, kind of. But basically, see, you have the ability to roll back in case of you thought there was some issues. So that is the point, which is very rare. See, how many times you really roll back your tables, right? But in case needed, right, you have 7 days. What are the versions you can go back? In fact, there's a concept Harun will be discussing called vacuum, which cleans the files. If the vacuum is not done, you'll have they will be always there. Even though by default it is 7 days, but 7 days if you run the vacuum. If you haven't run the vacuum, see what are all this under the hood? What is this, Kishore? Under the hood, even though you are
Table.
saying versions, etc., these are all files, correct?
Files, yeah.
So you're adding a transactions, means maybe new files will be creating, or when you do append, or even when suppose the way it is done is, say you have a Parquet file. If you are inserting a new row, or especially the update, it doesn't open the file and update. It takes the file and do update. It creates a new file. The old file will be there.
Absolutely. Okay, Srini, got it. Yeah, now it makes sense now. Yeah, absolutely. Yeah.
Yeah. So when it's the versions, it clears. Oh, okay. These are the files I need to take care of it. So when you vacuum, what it is doing is it is removing the old files which you don't want. Are you getting it?
So
suppose, yeah.
So let's say the use cases, you have a bad job running daily at morning 7 a.m., right? And then it does some transactions onto the table, and then it executes some stored procedures or something. And halfway through, it has done, say, 1,000 records, it has inserted, updated, whatever, and then it failed. Now you want to run the job next time. So you want to restart the job, you want to clean up and restart, right? So that's when you roll back, let's say, using the timestamp or the version to the day before. So it failed today morning. So you roll back to the time when it finished yesterday midnight, or the time before that version or that date. You roll back to that snapshot, and then you run the job again. So next time. So that's one of the use cases, like, when you want to roll back using the version or the timestamp. Basically, when the job fails, most of the times when job fails, you have to do some cleanup if it is failed midway, right? So that's one of the use cases that you can use.
Suppose, Harun, okay, if I have created a table, okay, say a Delta table, I have written to that, and then since it's a managed table now, and if I drop the table, so the file behind the table also goes away. So if I want to roll back that, it is possible.
Drop table.
So see, I have a file, I have a Parquet file or a
Yes,
Delta.
I got you. So normally in a RDBMS, when you drop the table, everything is gone. You cannot recover.
Because we talked about managed table and external tables, right? So what we talked is if a
external
managed
table, anyways, you will have all the files.
Yeah, if it's a managed table, and if I drop the table, so the file behind that table also goes away, right? Okay, so now in this case, is there a use case, or is there a way we can roll it back?
Yeah, that's a good question, Kishore.
Yeah.
There are options from the cloud to see. What is happening is when you delete, it's deleting in the cloud, right? Correct?
Yes, yeah.
So the cloud, Azure and AWS, they have options, utilities, where you see they do soft delete. They don't do just delete.
Okay.
So when you delete, even S3 files, it's a soft delete. For you, it is delete, but they vacuum it after 1 week or something. So there are some thresholds. Yeah, there are options. No, don't worry. People don't want to lose the data.
Data, right? Yeah, correct. Yeah.
Because storage is cheap.
Yeah, but again, most of the time you're using the RBACs, right? Role-based access. Not everybody will have access to drop tables or all that is.
Yeah, correct. Yeah.
Okay. So let's come back. We'll revisit all of those use cases. You can just do a create and do that and check what is happening when you
Sure.
go into the cases. Okay. So here, as we said, if you want to restore the table to a previous version, can we do that? So what happens? So you go back, do the restore loans delta table version as of. So what is the version you want to do? Okay. So if we run this, it says cannot restore because there is no version 16. If we see in the history, there are only up to version 15. That is the latest version, right? So that's why you cannot do that. So what we have seen here, we'll see it latest version, whatever 15 is until, you have 231,000 rows and, we have all the credit score here. So if we go back to the previous version, let's say 10, we have 124,000 rows with no credit score column here. So we will roll back to version 10 this.
Kishore, again, want to make sure everyone, these are the features that are available, right?
Yeah.
It's not that every day you will be doing it.
Right.
So let's
Yeah,
ask Sahil, Sahil, how many times you guys rolled back your tables?
Yes, so Srini, by default, you mentioned the 40 days is there, but we are maintaining at least you can say 50 days. So we do have some job which is running in the background. We have this job weekly, and it runs the vacuum command like once in a week only. Like we archive only like 50, 60 days of data.
Okay. Okay. Don't worry. I think, it's good. That's good. But did you roll back any time?
Never, never, never. So as I mentioned that everybody cannot have the role. It's all role-based access, so nobody has like drop permission to drop any table or that kind of permission to do that.
But any mistake you got data where you had to even roll back to your version?
No, Srini, not
exactly.
Not as of today.
It's very rare.
Never.
At least even,
Very rare. No, never. But we never has that scenario.
we have seen at Starbucks, Kishore, Purnima, where the data was corrupted, which nobody knows. The latest version data, the Parquet file got corrupted. Nobody knows the reasons. So then they had to roll back and rerun the process.
Okay.
So these are all exceptions. Don't worry. Even the 5.5 years work I did for multiple customers. Only one case I have seen it. Okay, but understand. Okay, hey, these are the features that are available. That makes sense, Kishore?
Yeah. Yes. Sure. Yes.
Okay. So we have restored version as of 10. Okay, and then we can just we will run this. So when you guys practice this, based on how long you run your streaming, your version numbers might be different and the counts might be different. So please check that when you are running this, practicing this.
So Harun, when you're restoring, it will replace the current version, right?
Yes, we'll see that.
And the current before replacing the current version, is the current version of the table is also stored as a version?
Yes. So once we have done this as a version 10, we have restored it. So now we have 124,000 rows, same as what we are seeing here in the version 10, 124, 2005, and then we don't have credit score here. I'll go back, refresh, go to history, version 16 is a restore operation done on this.
That's a good question, Siva.
Okay. Now let's try to again go back to version 15 and see what happens here.
So you guys are playing around, man. We never did this many restores.
Okay. Yeah, so I come here. They really want to go deep into the concepts.
Shiva, you like this?
Oh yeah, definitely, Srini. In RDMMS, like data management, it's all different, right? So a lot of manual effort is needed, and yeah.
That's very powerful.
Okay, see here, even if you did version 16, latest one, you still have the version 15, 231,000 rows with credit score column here. Okay, so which is matching with your count here before you did the restore. So you still want to go back to the original one. Again, you do a restore to version 15. So which will again become your version 17, which will be same as your 15. So don't get too much confused into this. It's just more like a Git versions.
So Harun, we can also use it restore was as a timestamp instead of version also, right?
Yes. Yeah, timestamp also you can do. It's just the same thing. You, instead of version as of, you do timestamp as of, and then you give the this whatever timestamp you have.
So we don't need to mention the version, just timestamp in the statement, right?
Yeah, no need to do the version, only just as the timestamp.
Okay.
And you cannot overwrite a version, right?
No, it is
it's a static.
only.
So
It's a
once you,
history, right?
yeah.
So yeah, that's what you do. If you restore back to version 15, it's not that it will erase the version 16 and 17. It will just create another version 17,
on the
which
top of
same as like version 15 on the top.
Okay. And when you do it, just a select star from the table, it will always pull your latest version
Latest, yes.
from one.
Yeah, absolutely. The top latest version snapshot. Okay. Okay. Yeah, moving on. Delete, update, and merge into. It's the DML support, what we want to do. So we take one record from here, one loan ID, and we will update that and see how delete and insert, update these records and see how the Delta table handles this. So we have this 4420 loan ID that we are using. Funded amount is 22,000. All of this data here, timestamp. Okay. So does it need credit score? Okay, that's fine. Now I'm deleting this loan ID and then trying to select again from the table. Okay, query return, no results. So there is no data. It's just like our SQL delete. So nothing much about it. It's just that, the other Parquet files, if you use, it does not support, only the Delta format will support these DML comments. And as we said, again, you can insert into the table. You can take data from any of the same previous version from the same table. So we knew this record is deleted in version, whatever the latest version, right? 17. So if you go back to previous version, that record will still be there. Okay, so we don't want to roll back or go back to entire version 17. It's delete operation. Okay. So if we go to 16, we will still have that record in there. So what we will do, we will select that record from version 16 and then insert it back into the current table. Or you can just say insert into, and then that is also works fine. They just want to show that you still have, it's same like rollback. Select some records from a previous version and then put it into the current version. That is also possible, just like time travel. So you are going back into the snapshot taking some data out there and then putting into the latest version. Okay, so affected rows, insert rows. So one row is inserted. Now, if we just check from the latest version, that record is back here. Okay, now update the same record where loan ID is this. Funded amount from 22,000 to we are changing to 20,000. So we can just do a select and then do a 4420. So that record is updated with 20,000 funded amount. These are just basic SQL commands that we do every day. But main point here is we can also use version as part of these statements. Can travel back in history, get the data and use that in the same SQL to insert into the current one. Now, once we do this, modify, update, delete, and all done. So how do we do a merge statement? It's like insert or update based on the existing data. Okay, so we'll go through this. You guys can understand. If still have questions, we will again revisit this in our next session. Okay, let's see here. So I'm trying to get new data again, 2 records, which has a operation that we want to do. This is the record to update and this is the record to insert. So this is loans delta schema. So what this is the type we are using batch streaming, right? So we are just using update insert. Don't confuse this. You don't need this for doing any of this merge statement. It's not mandatory to have to let it know whether you want to update or insert it, just to identify what we are doing with this. It will also work without this. So just not to confuse, let's just say something that we can write. Okay. So we are creating a temporary view with these 2 fields, with these 2 records. Basically, the schema is same. Okay. So this is the view merge table. Now, this is our source table, for example. Now we are taking these records from the source table, comparing against our existing loans delta table, and we are doing a merge. So what is merge? Take the source data record, check in the target. If the record already exists, then update it. If the record does not exist, then insert. It's just an upsert statement. Okay. So you match on the keys. If the record is found, you update. If the record is not found, you insert. And also when you update, you can you have control as to know which fields you want to update specifically if you want to. When not matched, then you can also then you insert all the record, the entire record into the table. So this is the merge statement. Merge into loans delta. This is our target table as L, using source table. Source, it can be a table or you can use a data frame that is created as temporary view. You can refer here or you can directly refer data frame in the SQL. That is also fine. As M on. So you give the matching keys to match, just like join these 2 tables. It's just like a join. And for each record, when it is matched, then update. Update what? It will always update the target L, sets star. So you can actually, instead of star, you can say set just 1 column if you want, L dot funded amount equal to M dot funded amount. You're just updating the funded amount. You're not changing anything else. That also you can do. Or you can just set star, which means except for the ID, all other columns are updated. So 4420, 22,000, 21,500. So this is the data, right? So this is what it is going to update. So what is the current data we have here? Funded amount is 20,000. Paid amount is 1,050. So it will go to 22,000 and 21,500 when you update that. When not matched, which means that that record is not found. For example, this record, which is not found in the target, then it will insert the data. So that is the merge statement that you write when you do the upserts, incremental data updates into the target. Okay, 2 rows updated. 1 row is 2 rows affected, 1 row is updated, 1 row is inserted, no rows deleted. Okay, so you can also write a delete statement from the target based on some conditions. So when it is, it's like a, what you call, except join, something like that, where you check in the target if it's there and source it's not there, or some based on some conditions, you delete the record in the target. That is also possible you can do when you match with the keys. Now you can check the data. So these are the 2 rows that we have inserted. So 44th is funded amount and paid amount have changed here. Type is what we put. So it will just go into type. As I said, this has nothing to do with what, whether you are updating or inserting. So I didn't want to confuse. So I just put some random characters in there. So this has no significance in the merge statement itself. It's just data. Okay. So this is the merge statement. I will stop here. We will discuss these vacuum, optimize, and these are just concepts again that we will talk about. So we will revisit this in the next session and go through these concepts: vacuum, optimize, Z-order, and also some delta log on Wednesday. All right, so that brings us to the close of this session. How do you feel? Please share your comments, feedback, guys.
Yeah,
Chandra?
this is good. This is good, Harun, definitely.
Good, Srini. Good, Arun.
Mhm.
This one, yeah.
Yeah, this is the first time that I'm hearing about the time travel. I mean, in terms of Databricks and, in terms of, so no, this is definitely good. Yeah. So one quick question though. So when you created that loans table, right? Initially, like the first time, when you created the Delta table, did we say like, your loans ID is your key on the table on that?
No.
Okay.
There is no key. You can match on anything here. It's not the key thing. So when the merge statement does not have to be always on the loan ID. You can match on anything.
Okay. So when you're doing your upsert, you can still use any column. That's what you're saying?
Yes. Yeah, you can match loan ID and you can match loan ID and funded amount. It's how your data is structured.
Okay.
Yeah, normally when do you want to update? When you identify it's the same row, right? So how do you
Yeah.
identify it's the same row? Based on the keys. But the
Yeah.
keys is not something it's defined here. You can define it, or you can just identify it as part of the operations, which keys you want to have as a key, which columns you want.
Okay.
Yeah.
Just a basic question. So in order to define a delta table, we need to have format delta, mode append, option merge schema true. So that will make any table as a delta table.
No, you just need to have option. You just need to have format delta, or even default it's delta only. If you write a Spark data frame, unless you mention format as something else, the default format is always delta. So you just write table, it will write as delta.
Oh, so any table can will have all these features?
Yes.
Oh.
Yeah, earlier, few couple of years back, that is a declaration is a mandatory, whether it is option Parquet, option Delta, something like that. But now, if you don't put any option, by default, it's a Delta table. Okay.
Right.
So if you want just a Parquet table, you will keep option Parquet. Does that make sense?
Yeah, it makes sense. Yeah.
Yeah. So
Okay.
format you get delta, but schema you need to schema evolution, right? Merge schema you have to specifically give. By default, it's off. So it does not, by default, it will throw error if the schema is changed. I mean, that's the expected behavior, right? Unless you want to specifically allow the schema evolution. So it's the business decision how you want to take that. So that is why you specifically give that option if you want to enable the schema evolution, merge schema true. But all this time travel, history, the merge, insert, update, delete, with all comes by default with the delta table, which is default format delta.
Got it. What is the use case in production? Like what type of tables do we make it into, like put it through this delta? Like is it like dimension tables or the fact tables? Because you have millions and millions of rows, and somebody has to maintain the cluster size in the backend for it to keep these versions.
All the tables. Purnima, all the tables by default, 99% of tables will be Delta tables only when you're using Databricks. There are few cases where customers think we continue to maintain those Parquet tables. So it is not an optional. The storage is Databricks uses Delta storage. Delta storage has a lot of advantages. So all that any tables you create on a Databricks is predominantly Delta tables.
Got it. So you have to control vacuum in order for us to control the cluster size and how much data we can maintain.
The storage aspect. But now there are, if you use what you called a DLT, there is another tool. It has auto optimize, auto clean, all those things. And there is new concept coming, predictive optimization, where Databricks itself does the vacuum. But vacuum will be another job, periodic job, nightly running. They will clear all those things. Those are just maintenance aspects. So it's not just for this table, that table. They just run one vacuum every night. It looks to all the tables. It start doing. It's like vacuuming our house once in a while. No. So it's not an overhead. It's a general utility. That's it. Any questions, Param?
I'm good, thank you.
Yeah. So again, guys, don't get confused. So anything is table, that table will be a Delta table in that if you are using Databricks. So we worked with a customer. So they have all the tables, Delta tables. Even some tables, Parquet tables, they will convert it. There are tools just to convert Parquet table to Delta table. It will convert. What it is doing, it is just exactly your Delta table, nothing but a Parquet table only, with additional that transaction log, which helps you to do the updates, which helps you to maintain the history and all the benefits. And very, very useful and high performance is also, right? So definitely they use that only. They don't go for just Parquet files, which you can't even update. That's the thing.
Right.
So, super awesome. Any comments for Harun's session today? Sahil, how was it? Prasanna?
Yeah, it was very good.
Prasanna,
It
how was the
was
session?
a lot of things new things for me, especially.
Yeah, keep as a placeholder. These are all utilities where you can read and, oh, okay, these are the options are there. Chandra, Subbu, Akshata?
Yeah, there are new things like acid and these inserts. I got to know in this session.
Yeah, these are very good stuff. Since this is so powerful concepts, that's why this has so much demand, guys. So it is so powerful. More than 10,000 customers uses this. Handling huge data. Doing this type of things on ordinary system is next to impossible. So a very highly efficient system here and there with some softwares you may be able to do, but as a package, this is a complete package, secure system, intelligent system with a lot of tools, a lot of efficiency. Overall, it does meets the organization needs compared to any other platform in the market. It's the leading platform, very predominantly growing, very dominant. It's a very powerful use cases you built. So you add a lot of value for the customers. So there is a lot of growth. You can become lead, you can become even future manager, director, whatnot. So it's a wonderful field. Focus, learn the things, try to articulate, ask your friends, sit and learn, This will make you grow. And these are not hard concepts. Only thing is you need to understand and think all those things. But anyway, everything you don't need to do now. Just get to know basic, get into work, start doing it. As time passes, you'll become strong. Subbu, you there?
Yeah, Harun, thank you very much. This is Chandra. Thank you very much, Harun. And all people are helping not only from one perception, because based on multiple people experiences and perceptions make us more understanding on these concepts and the technologies.
Well said. Well said. Sahil, we are good. Purnima, we are good for today.
Yes, Srini.
Shiva?
All good, thank you.
Yeah.
Yeah, good, Srini.
Prasanna?
Yes.
Kishore?
Yeah, good, Srini.
Good stuff, guys. Hard work doesn't go anyway. Enjoy your rest of the day. Good job, Haran.
Thank you, guys. Yeah.
Keep it
So
going.
it'll take some time for the videos to get processed. More than 2 hours it takes. So I will update by end of the day.
Super.
Can you update the notebook, Harun, even though not the video, but this
Yeah, sure.
notebook?
Yeah. I will update the notebook immediately in some time. Sure.
Super awesome. I think they are very excited. They want to start. Okay.
Thank you.
Super. Great job, guys. Great teamwork. Let's keep it up and make sure you guys stay in touch. Super. Don't get lost. Get to know who
Sure.
people are. Your
Sure,
job,
sure.
your growth in the job is not just by your knowledge, but how many people you know, how they perceive you. It is so important, guys. Don't neglect. Now, there's going to be a lot of pressure in the market in the coming years, but we are going to be exceptional. We are a different league. Okay, let's do a great teamwork. Okay.
Thanks, Srini. Thanks, Harun.
Thank you, Harun.
Thank you,
Thank
Srini.
you.
Thank you, Harun.
Thank you, Harun.
Super, guys. Enjoy your day.